Let's start revising discriminants. So we know the discriminant was from your quadratic formula. Now, let's zoom in again. What was the quadratic formula again? Can I please have, let's go into Murphy. That's a quadratic formula. Yep.
Plus minus root b squared minus 4ac.
Beautiful. This is your quadratic formula, and what's the quadratic formula used for, Anthony? Very good. It is used to find the x-intercepts. Now, in a quadratic, if you think about it, we know that it looks like a parabolic shape, right? So that means there are three scenarios that it can happen. You can have the axes where it touches exactly once, so you get one solution. You could have another graph that doesn't touch it at all, so that's no solutions. And then you could also have a graph where they pretty much, what color haven't I used? I'll do black. You could have a graph that crosses twice. So there is possibility when you're finding the x-intercepts, you will get either 2, 1, or 0. Okay, so I'm going to write here 2, 1, or 0 scenario. And all of that in this formula is determined by whether you can square root a number or not. That's where it all begins. It all begins on this section. Because the plus minus, well, you can always add and subtract a number. And negative b is just a number. And then you divide it by a number. All of these have no restrictions. The only restriction you have is what you can square root. Now, we know that there's a certain number we can't square root. What can't we square root? Irrational. Well, you could technically square root irrational. What? Negatives. Okay, negatives are the only numbers you cannot square root, because square root is the opposite of squaring, right? So that means you have to be able to square a number that gives you a negative number. So if you think about it now, if I ask you square of what number will give you a negative, there's no number. Every time you square, it's always positive. And because of that, there's a problem here that when b squared minus 4ac, whatever the letter b is, whatever the letter a and c is, it doesn't matter. The point is, when it is a negative, the square root of a negative is impossible. So if it's impossible, what does that mean? If it's impossible, it means it's impossible to find an x-intercept. And which one of these scenarios represent no x-intercept? Clearly, this is the only time that it's impossible to solve for an x-intercept because you have none. That's why if b squared minus 4ac, they say if it's less than 0, all they're trying to tell you is that if this thing inside the square root, if it's negative, you'll get 0 solutions. That's all it was. It was just based on that logic that there was a restriction on what you can square root. And then the other logic was, well, what if you square root 0? Because you're saying b squared minus 4ac, what if that was equal to 0? Now the logic is, what's the square root of 0? The square root of 0, Luke? 0. But then if you took negative b plus 0, or you took negative b minus 0, there's no difference. Because 0 is 0, there's nothing there. So you actually end up with only one answer. Because if you got whatever negative b is, let's say it was like 5, negative 5 plus 0 or negative 5 minus 0, it's going to be the same answer. There's no two different answers. It's going to be one answer. That's why they say when the discriminant equals 0, you end up with one solution. It's all through logic. And then your final one was the idea that, well, what if you can just square root a number? So it doesn't matter what the number is, it has to be positive. So that's why they say when it's greater than 0, it just means when it's positive. If you can square root it, doesn't matter what that number is, you're always going to have negative b plus whatever that number is, and then negative b minus whatever that number is. So of course you're going to have two different answers. One adds and one subtracts that number, so that's why you change. That's why there's two solutions. And that would represent having two different x-intercepts, because that's what the quadratic formula is used for, is to find the x-intercepts. Okay, so that's on a theoretical sense. So I'm showing you on a logic why this is true. So we know this is now two solutions. I've drawn the graph for you. Now, let's apply this. So this is known as the discriminant. We know the pictures. I'll draw it in again. So 0 solutions would have to be the one that has no intercepts. 1 solution has to be the one that touches the x-axis only once. And then the other one crosses twice. Okay, let's do an example today then. So what's the challenge today is you're going to combine sketching, okay, sketching with understanding exercise 3G, which is greater than, less than, or equal to, because you've got 3 scenarios there, yeah? And so 3G was about you understanding which part of the region of the graph are you interested in, and then looking at the x-axis. That's what was challenging from 3G. You apply that here, okay? So I'll show you, and I'll try to describe it through 2 graphs. There's 2 graphs that you're going to have to get your head around. One is the discriminants, and then one is the actual graph that you're interested in, yeah? So let's take this example here. Example 1, you've got an equation. This is a quadratic equation. How do I know? Because it's x squared. You've got 3x squared minus 2 times mx plus 3. Now if I asked you what is my a, b's, and c's, let's look at it. Let's zoom in a bit. What is my a equal to? What's my b equal to? And what's my c equal to? Let's go with Ben. A equals 3. What do you think b equals to? Negative 2m is correct. This is your b. This is the number in front of x squared. And then your c must be positive 3. Great. Now here's the problem. I don't know what m is. So if I type this onto your calculator or Desmos, let's go to Desmos. I'm going to find Desmos on my, it's over here. Here's what we have. I'm asking you to sketch 3x squared, and then you've got negative 2 times m times x plus 3. You see, this is the graph if m was 1. We just don't know what m is. But when m is 1, how many solutions can you see? How many x-intercepts? None. Okay? So what the question is now asking is, as you change m, the number at m will determine whether you're going to get 1, 2, or none x-intercepts. The question is, what numbers can you choose for m if I only wanted 1? See, if I were to create a question for you, sometimes I do this myself. Sometimes I'm like, all right, I like the number 3, because it's a small number for students, and I like the one intercept at 3. But what number should b be so that I know when you calculate it, you're only going to get 1 x-intercept? What if I didn't want 0 intercepts? I wanted only 1. What number must m be so that I can only get 1 x-intercept? This is what you're training to do in exercise 3I. Okay, the ability to solve what should m be so that I will get 1 x-intercept? Or is it even possible to only get 1 x-intercept if I have a is 3 and c is 3? That's what we're doing today. Yeah? So the challenge is to think of not trial and error, not with m. So I don't want you to go into Desmos and do this, where you play around with m, and that's pretty much us trial and error. We sketch every single m value that you can come up with, and you start to see a pattern. So if I zoom out, can you guess roughly, just looking at the pattern, look at the numbers of m, roughly what numbers will I have 1 x-intercept? Just roughly. Just look at the graph. Roughly between what m values, or what m values will I have such that I will have 1 x-intercept? Right now it's 2, 2, 2, 1, 0, 0, 0, 1, 2, 2, 2. Which m values? Is it going too fast? I'll slow down a bit. So at m3.3, I've still got 2. I shift it over a bit. That's 3.9, still 2, still 2, 2, 2, 2, 2. And I slowly come back. So that's 3.3. 3.2.8, 0. And I keep going, and I keep going, and it goes all the way. At some point, I had 1 intercept somewhere, and then 2, 2, 2, 2, 2, 2. What values of m did you kind of guess just now? to make it one intercept, what numbers of m must I have, roughly? Anyone know to number? -3 and 3. Let's see. So if I go back to -3, this is -3. It does look like it could be 1. We haven't tested it yet. And the other one is if I go all the way across, let's see, is it about 3? And it is. Well, it could be. But how do we do this? We trial and error. I changed a lot of the m values to get there. Unless you're willing to sketch a billion graphs, that's not the smartest way or the most efficient way. So there has to be a better way. So today's lesson, I'm going to show you the better way. So here we go. The first question was what I just asked you just now, which you came up with the answer as m equals 3 and -3 by trial and error. We don't want to do trial and error. It's nice that it's a nice whole number, but it might not be a whole number later on. It could be a fraction, all right? So let's see how we would solve this. So remember, to get one x-intercept, we know that the formula A is currently 3, B, which can be changed, but C is 3. When I sub it into this formula, I only want one x-intercept. But the only way to get one x-intercept was if the discriminant, whatever you're square rooting, ends up being 0. So this is key. This is all we have to make sure, that whatever b squared minus 4ac is, we have to make sure it's equal to 0. So let's do it. Here's my b squared. Let's write it out. So discriminant equals b squared minus 4ac. My b, Ben told us before, was -2m. So I'm going to write -2m squared minus 4 times a, which is 3, times c, which is also 3. All right? So I'm just filling it in. Here's your b. Here's your a. And here's your c. All right? Let's simplify that. You get the discriminant is equal to, now -2m squared is -2m times -2m. So you get positive 4m squared minus 3 times 3 is 9. 9 times 4 is 36. So this is what I get. And this is where it gets confusing for students. You see, you got a graph. This is a pattern. For every m value you chose, did you notice when I was moving m, did you notice it was going in a pattern? So I'll go back. Look at this pattern. I'll play it again. There's a pattern on where the shape is going. Do you see this pattern? If I had to trace it, there is a pattern here. And that pattern is what you're analyzing. You're analyzing that pattern. It's going in a certain pattern. It's going up and it's going back down. It's a parabolic shape. Can you see that? So this here is a description. Whoops. Whoa, what happened? Where'd I go? This here describes the patterns for m. You want m, remember, to get one solution, what do you need? You need the discriminant to equal 0. But I don't want you to just look at it as how to do it, because I can teach you the how. I'm trying to get you to visualize what's happening here. You've got a graph where it's no longer the y-axis anymore. This is your discriminant axis. And these are the m values that you're testing. So when m is 1, then it's 1 squared times 4, take away 36. Now logically, 4 take away 36, is that negative, 0, or positive number? So if m was 1, what would the discriminant be if m was 1? What do we have? Have a guess? If m was equal to 1, what will my discriminant be? Negative, positive, or 0 number? Negative, logically, yeah, because 4 times 1 squared, 4 take away 36, it's going to be negative. If it's negative, it tells me there should be no solutions. And this is why, in the graph, when I change it to m equals 1, it's true. There's no solutions. You can do the same thing again, and you can test, well, what if m was 5? 5 squared is 25. 25 times 4 is 100. 100 take away 36. I don't care what the answer is. I just care, is it a positive, negative, or 0? It's going to be positive. So I expect that 5 should have 2 x-intercepts. And you can see when I change it to 5, there's 2 x-intercepts. So you can see what I mean by there are two graphs here. There is the discriminant graph, and then there's the actual graph that you want, right? So your skill today is to sketch this graph and analyze it. So you have to pretend in your head, this is your X and this is your Y. All right, but really it's the discriminant. So you're looking at your discriminant. This up here represents when discriminant is positive, because that's above the 0, yeah? This represents when the discriminant is exactly 0. And then down here represents when discriminant is less than 0. So any part of the graph that is down here tells me no solutions. It means the graph will never touch the x-axis. Any part of the graph that sits on the x-axis, those values should be when it will have one solution. And then any part of the graph that is above this x-axis, that will tell me you will have 2 solutions. This is what's confusing for students. I'm going to write it again. This is when discriminant is greater than 0, because that represents discriminant. So all the numbers here are positive. So when discriminant is positive, two intercepts. This represents when it equals to 0. This represents when you have no intercepts. So if I asked you to sketch this graph now, 4m squared minus 36, that's a turning point form. Down by 36, and it's a smiley shape because the number is 4. So if I were to sketch it, I already know it looks like this with a turning point at negative 36. If you weren't sure, I can show you here. And this is what I mean, you have to be able to sketch well. So y equals to 4m squared, x squared minus 36. Can you see what I just said? That's my graph. But remember, this is not the graph of your actual graph. This is the discriminant graph. That's what is confusing for students. So this graph here tells me, which is what I've drawn, I said any part of the graph that is below, that represents discriminant less than 0. So any numbers between this point to this point, this bottom part of the graph, is going to give you no solutions. Any part of the graph that is exactly this point here, because whatever that m value is there, discriminant is clearly 0. Whatever this point is, whatever that m value is, discriminant is exactly 0. That's what we're calculating here right now. Because we're saying, right at that point, discriminant clearly is 0. What is the m value? So how do you do that? I literally, in this equation that you've got, we're saying, if this is 0, let's solve for m. And this is what you've been doing in the past exercises, 3C and 3D. Inverse operations or difference of perfect squares, it's up to you. I like doing inverse operations, so I'm going to add 36 on both sides. Here we go. Add 36 on both sides because that's a minus 36. Divide both sides by 4. And I'll write it in, so plus 36, divide by 4, divide by 4. And then the last one is m must be the root of 9, but remember when you square root, you have plus minus. Don't forget the plus minus. So here, m must be, root of 9 is 3. And that's exactly what Anthony, or we guessed before from looking at decimals. That tells me when m is 3, I'm going to write it here again. So when m is 3 and negative 3, that's when discriminant is 0. So on the graph, these 2 points, when m is negative 3 and 3, it will have only one solution. How did I know that? Because the discriminant I know is going to equal to 0. And if the discriminant equals 0, you zoom back out and you think about your x-intercept formula, quadratic formula. If it's going to equal to 0, plus or minus the root of 0 is going to give you only one solution. So if I were to create a SAC for you, and I wanted to only have one intercept, I work this out myself, and then I say, all right, m has to be 3 or negative 3, and then I have a choice. If I put a 3 there, there'll be 2 times 3, which is negative 6. And so all I have to do now is I type in the equation to test it out. I would say, yep, all right, let's try it. I will give these students in my SAC, I'll write y equals to 3x squared minus 6x plus 3, and it guarantees you're going to get one intercept. And that's how I make your SACs. I make it on purpose because I either want 1, 2, or none, but I can control that. I control what you're going to see because I figure it out what I want. Your ability today is to get to my level at that point where you can look and then play around what m values you can have to determine that. So we started off with not knowing what m can be. We did some calculations, and now we do know what m can be, and I had a choice. I could do 3 or -3, and both equations would have had one solution. So you can see here, if I did y equals 3x squared, and instead of positive 3, I could have done -3, so plus 6x plus 3. These two graphs represent when m is either -3, so -3 times -2 is positive 6, or positive 3 times -2 gives you -6. Does that make sense? So there's two graphs there. One was the m versus discriminant. This is the actual graph that I would give to you in a test. But your ability to determine, well, how did I get here? How did I come up with these graphs? And how did I come up with these equations? That's what you're trying to do today. Make sense? Okay, so once you get those 2 points, it's really easy now. Once you've got this graph, these 2 points, -3 and 3, is when it's exactly 0. So if they ask you no solutions, well, where's no solutions? Down here. This is when the part of the graph will have discriminants less than 0. That's the discriminant axis. This is when discriminant is negative. So any values that you choose between -3 and 3, so this is why it's similar to exercise 3G, your ability to read the inequalities here. If you want discriminant to be less than 0, clearly the graph is between, m needs to be between -3 and 3. That's part number 2. So if you want no solutions, if I wanted you to have a graph that's not going to end up with any x-intercepts at all, I would choose an m value that's between -3 and 3. So you can come up with a number if you want. So m equals 1, no solutions. M equals half, no solutions. I can come up with any number there, and I promise you the result will be no solutions. So we can test that again. I'll go back again. So here, instead of -2, let's say half, because I just said -3 between 3, -3 and 3, choose a number, and it should be no solution. So if I said m was half of 2 is 1, and look at that. It guarantees you're not going to get any solutions. That's the power of analyzing this graph. The power of analyzing the discriminant graph to determine what the true graph would be. That's what you're trying to do. And if I wanted two solutions, 2 x-intercepts, well, clearly this region up here, this is when your discriminants are positive. That's when your discriminant is positive. So what numbers can I choose? Discriminant to be positive, based on the graph, I need to choose a number that's less than -3 or greater than 3. Any number that you choose in this direction will guarantee that the discriminant is above. Any number that you choose in that direction guarantees that you're going to get a discriminant above or greater than 0. That essentially is the essence of exercise 3I. I'm not saying it's easy. This is probably one of the most conceptual because there's a lot of basics here. 1, you have to be able to solve. 2, you have to understand the theory. 3, can you sketch? But to sketch, you needed all the foundations that I just mentioned from year 10. So A, B, C, D are all sketching. Everything here is based on your foundation. Okay, so being able to complete the square when you get a random equation here, you have to be able to factorize it, sketch it. G, analyze. Put it all together in one exercise. So one exercise, one question, I can learn a lot about you. I can see how well you understand quadratics. Does that make sense? Yeah, so it's quite tricky, but hopefully that paints the picture. So once you can find the graph, it's easy to read the rest. Okay, so even though there's 3 parts to it, the first part is the hardest, so getting this. Once you get that in the graph, then answering these next 2 parts is easier. Cool? All right, so that's my one example. You guys can have a go with this. This is a bit harder. Why? Because there's now 2 letter M's. The other one only had 1 M, but same concept. I'm going to pause the video, give you some time, have a go, and then I'll give you the answers to it. Okay, so have a go. This one I'm going to pause. Common mistake is when you're identifying your A, B's, and C's. This C is a negative M. If you just wrote M itself, that's one error that could occur. Another one is not getting used to writing this as B. So M minus 3 is the B. So if you've got the A, B's, and C's correct, so this one, and this one, then it's about you substituting into b squared minus 4ac and then simplify. So notice I've got n minus 3 squared, negative 4 times a times c, double negatives positive. Getting the first step, that's what we look for. So did you start off right? Then from here, it's then about your previous skills. So from 3a to, about 3e is about, can you simplify this expression? It's quadratic. At first I was going to do difference of perfect squares, but that's not a minus, and that has an extra m, so I can't do it. Because I've got an extra m, the only other way I can do it is only expand this bracket, and in exercise 3a, we know expansion of this is square the first, double this, and then square the last term. That's how I got the next line here. Negative 6m plus 12m together, those are like terms, so hence together it's positive 6m. And the next thing I noticed is that's a perfect square. Because if you do complete the square, you can see in the second last row here, half the b term, which is 3, and then square root of 3 gives you 9. But I broke it up for you just in case you didn't see it. I broke it up by doing cross method. Cross method brings it back to a perfect square anyway, right? Now, some students can get up to this step. So those are the 3 that I can then determine where you're roughly at in your algebraic skills. Well, say you get up to this part, which is great. Doesn't mean they get it. So the question is saying, show that the solutions are rational for all values of m. So they might get here, but it still doesn't mean anything to them. Can I get a show of hands who did actually get up to this final step? Just to know. All right, good. Excellent. Now the interpretation. This is your discriminant graph. So the reason why I had a graph here is for you to sketch it and analyze it. So if you were to sketch this is turning point form, exercise 3D. What's the m plus 3 tell me? What do I know about the graph? Up, down, left, right, inverted, upright. What does it tell me? Yeah, it just tells me left by 3. And is this a smiley face or is it a frown face, Massing? Smiley face. It's upright, right? So if I were to sketch this, like Ben said, to the right by 3, left by 3, and a smiley shape. What do I see from this graph? Remember, this is not your y values. This is your discriminant. And this is your discriminant axis. So what it's telling me is the graph clearly touches the axis right at negative 3. So when it's negative 3, discriminant is clearly 0. When it's 0, that means when m is negative 3, I can get one solution. Meaning if I subbed now negative 3 into this equation, whatever this final equation is, it's only going to have one intercept. But then notice that if I chose any numbers less than negative 3, the graph is above the x-axis. So that part of the graph is your discriminant. That there, every point here represents a discriminant greater than 0. But if it's greater than 0, if all these points represent a discriminant greater than 0, that means all these m values that you choose in that direction will have 2 solutions. They all will have 2 x-intercepts. No matter which m values you choose, it corresponds to a discriminant greater than 0. So that means if you chose m less than negative 3, you'll get 2 solutions. But if you chose m exactly negative 3, you'll get 1 solution. Then what if you go the other direction? What if I said, well, from 3 onwards? Same concept again. Can you see if I chose any m value here, it corresponds to a point where discriminant is greater than 0. I can choose this m value, and clearly discriminant is also greater than 0. Doesn't matter which m value, according to the graph, it's again above the x-axis. And because of that, I know that no matter which m value you choose greater than negative 3, when m is chosen to be greater than negative 3, what's going on? M is greater than negative 3, I have 2 solutions again. This is what they were trying to say, that show that or prove that you understood this is a perfect square. It's never going to be negative. There's no way I can come up, if I came up with this sort of format for you in your test, doesn't matter what m value I choose, you're never going to get a graph that has no intercepts at all. The graph is always going to have an intercept. And I can prove that by going to Desmos now. Let's go to Desmos and type in that equation, okay? So I'm going to type it all again. Y equals 3x squared plus m minus 3 times x plus, no, minus m. Times x minus m. Watch this. I'll press play, and there will be never a time where this graph will have no solutions. It always has one. It has 2, 2, 1, 2, 2, 2, 2, 2, 2, 2, 2. It's 2 intercepts, no matter what m is. I can choose, and right now m is restricted from negative 10 to 10. I can say, let's do negative 100 to 100. Let's go steps by 2, yeah? So if I press play now, and I zoom out, you'll see it's 2, then 1, and 2. It doesn't matter what m values you choose. It will always be 2 or 1 or 2. There's never 0. And that was not by guessing. That was by analyzing your discriminant graph. Because the only way you're going to have no solutions is if the graph was even possible to be in the lower region. This is exercise 3G to get what I'm saying if you haven't done it yet. What I'm doing there is analysis. Over here, that's your 3A to 3F plus H, so quadratic formula. Your ability to simplify your expressions, factorize and solve, that's what this is. That's why in the one exercise, it tells me a lot about your abilities, what you can do to get this graph here. Make sense? All right, so your goal is to work towards this. This is at the year 11 level. Been revising for the last month or so, just to make sure your year 10 foundation is good. Then you move over here. Cool, and then from here, we just move forward. So we always rely on every skill that you learned there, and every chapter we move forward, we'll do a bit of this, and we'll do a bit of that as well. So throughout the year, you do get practice. So don't give up, you just stick to it. Just keep practicing, and then you get better. After 6 months, doing the same thing over and over, you do get better. It's just whether you can handle 6 months of doing lots of algebra. Cool? So that's methods. Easy? Well, not easy, but it's something to get and strive for. Yeah? All right, I'm going to stop the video.